my y would be 0. Then I should go a little bit in each direction on either side of that 5, so I might go 3 and 7 and 1 and 9. So I'm just taking 2 on each side of this point that's going to give me the 0 because I want to see the V shape for the absolute value. Put in the 3, so I have 3 minus 5, that's going to be a negative 2. Take the absolute value, it's a positive 2. 7 minus 5 is 2, take the absolute value, still 2. 1 minus 5 is negative 4, take the absolute value, positive 4. 9 minus 5, 4, take the absolute value, still a 4. So if I graph this, if I go over to 5, 0, 1, 2, 3, 5, 0, and then 3, and I'll go up 2, 7, up 2, 1, up 4, and 9, up 4. Now you can see the V shape, and I know it has a dashed line, so I'm going to make a dashed absolute value graph here. And here. And remember, even though it's an absolute value, it still should have arrows on both ends. And then I want to know which way am I shading, so let's try that 0, 0 just as a test point. If I put it in, it should be 0 minus 5 is greater than 0, and negative 5 inside the absolute value changed to a positive 5. It's a true statement. It means that the shading that will allow that 0 to be included is going to be appropriate. And then I need to graph the y is greater than or equal x squared. So again, I'd like to use an xy table. And I can see by the squared that my values are going to get large very fast, so I might just go negative 3, negative 1, 0, 1, and 3. If I put negative 3 in, I have y, and I'm pretending it's equals just to get the graph right, negative 3 squared, so y equals a positive 9. And the same thing for the 1, y equals negative 1 quantity squared, so that'll give me y equals 1. And 0 squared is just 0, 1 squared is just 1, 3 squared is 9. When I go to graph that, I go to negative 3 in the x direction, 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 9 in the y direction, negative 1, positive 1, and 0, 0. 1, positive 1, so I have a point right there, and 3, 9, so it's going to be way up here also. It looks like it would be helpful if I put in a negative 2 and a positive 2 on my xy table, and the y equals negative 2 quantity squared will give me y equals 4. And the 2 squared, of course, is also a 4. So if I do my 2, I go up to 4, negative 2, and then a positive 2 up to 4. So we can kind of see the U shape here somewhat. And it is solid. There we go. There's a nice parabola. And I would use 0, 0, but it's right on my parabola. So this is one time when 0, 0 is not an appropriate number to use. So I might try 0, 1, 2, 3. This point right here. Try 0, 3 as a test point. And if I put 0 in for, or 3, I'm sorry, 3 in for the y, it should be greater than or equal 0 squared. So 0 squared. And when I square 0, I just get 0. And 3 is greater than or equal to 0, so that's a true statement, which means I'm shading inside my parabola also. Okay, so when I want to see the intersection and an and, that means I'm going where the values match both inequalities that I've graphed. And so I know I'm graphing inside of this parabola for the parabola, and I'm graphing outside the absolute value. So I want the part in common, and if I'm graphing all inside the parabola here, but I'm only graphing this direction on the absolute value, the outsides of it, then the part in common is going to be just the part inside the parabola but underneath the line for the absolute value. And the domain then is going to be values from here. This one's going to be a little bit tricky, so we're going to call this 1, 2, negative 2.5. And it's included because this is a solid line, and all the way over to, it's not quite a 2, we'll call it 1 3/4. This sometimes you have to kind of guess, and that one is also included, and the range is going from negative infinity, nothing, nothing, until 0, and the 0 is definitely included all the way up to this point, which we're going to call 1, 2, 3, 4, 5, 6, 7 3/4. And that will be a parenthesis because this top boundary has a dashed line. So that's really tricky to find the domain and range on there, and a little bit tricky because we're graphing two of our special shapes.